Good afternoon and welcome to today's webinar in Knowledge Miles, the 695th Lord Mayor's Lectures. In this free online lecture series, we address the connections in and around the square mile, like Professor Michael Manelli likes to call the world's coffee house, and how this might help us to tackle future global challenges. Today we have a wonderful lecture in store, the waves to space, the problem with space debris and the challenges and the opportunities associated with solving it, with Graham Turnock. My name is Jacopo Moratto, and you might know me as the person who's been behind this lecture in the past months. And as my last day at ZN, I'm honored here to convene this session for you today. Before we begin, just a bit of housekeeping from me. As always, my job is to get out of the way as soon as possible. Afterwards, we'll have the keynote presentation by Graham Turnock, and then we'll jump into the Q&A session. You can write your questions on the top right of the page. You can do this throughout the whole duration of the webinar. Just a reminder, all the lectures are recorded, and this webinar will be available after a couple of days on our YouTube channel and on our website on knowledgemiles.net. Now, without further ado, let's introduce today's speaker, Graham Turnock. Graham, we're honored to have you here. So Graham is a Special Advisor European Space Agency, and perhaps could you tell us a bit about yourself?
Thanks very much, Jacopo. So lovely to be here, especially as you mentioned, as I'm a liveryman, and very pleased to participate in the Lord Mayor's lecture series, having had the opportunity to meet with the Lord Mayor recently. I know that he's really committed to the science square mile, and so it's great to be here. So I'm a special advisor at the European Space Agency. I'm leading a program of work about accelerating the use of space, in particular sustainable use of space, so space helping the green transition, but also trying to ensure that we use space sustainably, and that's really the focus of the talk today. In a previous role, I was Chief Executive of the UK Space Agency, and I started off as a particle physicist. I'm pleased to let you know that maybe one or two people might be disappointed there are no equations in today's presentation.
I'm sure some people will be upset about it. All right, well, then without further ado, Graham, the floor is yours.
Thank you, Jacopo. So today what I'd like to talk about is the problem of space debris. But really, I'm using that to illustrate the vast growth that we're seeing now in the space sector and the number of satellites in orbit, and really focusing on debris to demonstrate that that problem is also an opportunity, and that there is an opportunity generally in the growth of the space sector for the UK as a whole, but also for the City of London. So if I could have the next slide, please. So if you thought space was about this, i.e. astronauts, what it is, but I have to disappoint you that the talk will be mainly, if I can have the next animation, about this, i.e. how we use space for our everyday lives here on Earth. In this case, mobile communications, especially where we're away from the mobile terrestrial network, for example, in poorly served areas or the oceans, but also satellite TV, although that's dropped off a little bit now with the growth of cable. GPS, though, is forging ahead all the time, but of course it's not just GPS, the American system, there's also the European system, Galileo, and then Russian and Chinese systems. Earth observation is often a poorly understood bit of space, but the same cameras that we can use to study the stars can be turned down on the Earth to understand what's going on the Earth, and that's been traditionally very important in understanding climate change, but also now massively important in weather forecasting. And we're moving into areas such as Earth observation being important in the management and monitoring of infrastructure and the mobile economies, such as tracking autonomous ships. And I won't really get into this much today, but also there's a huge area of space which is military space, which is essentially the application of the capabilities I've just described to defence. That said, I will come back to astronauts later, so I don't want to disappoint anybody. Next slide, please. So the last 10 to 20 years have really seen a huge growth in the space sector. Growth has been around 7% per year globally, which is about double the rate of growth in the global economy. And the space sector is now worth about $600 billion US dollars. A substantial part of that is the public sector, in particular military space, about 25%. And the US is the biggest investor in space with about 0.25% of its GDP going to space. And although you might think that's all NASA, it's not actually. The vast majority of that is the US military space system. Russia commits about 0.15% of its GDP to space. But there's also been a huge growth in the commercial sector, which amounts to about 75% of the global space sector, in particular in China and India, where that sector was virtually non-existent 10 years ago. You can think about growth in the space sector through the number of launches. In 2023, there was a record number of 223 launches, itself up from 178 in 2022, which was another record. And that compares to a little under an average of about 100 launches a year for most of the space era. So what's driving it? And that's really what I'm showing on this slide. Well, first of all, the lower costs of launch. You might think that rocket on the left is taking off. In fact, it's not. It's landing. So that's one of Elon Musk's reusable rockets, which is coming back onto a platform after launch. And that, of course, it makes launch a lot cheaper if you don't have to throw away your rocket every time that you use it. A bit like traveling across the Atlantic on a 747 and then ditching it in the sea at the end of the flight would make air travel a lot more expensive. Also, the miniaturization of space, in particular the use of components that have been miniaturized through the development of the mobile telecom sector. And you see here at the top middle what's called a CubeSat, which is the standard of a satellite. That box is indeed a satellite, 10 centimeters cubed. And we've been able now to squash what would have been in something the size of a washing machine into something that you can see there. There's also been changes in demand for services that space can supply and is particularly well placed to supply, such as the mobile and connected economy, and then the demand for precise navigation from things like automated vehicles and ships, and indeed precise agriculture, putting fertilizers exactly where they need to be, and using tractors in the most efficient way when harvesting a field. Also, the green transition is a huge driver of the use of space, both in terms of climate monitoring, as I mentioned, but also in terms of smart and green cities, bottom right-hand corner, and energy transmission, top right-hand corner. And then we have development in technology more generally, the most important of which is arguably AI, which can help us make sense of the vast amount of data that we can gather from space, looking for things like changes on the Earth's surface, and attributing those to particular objects, such as ships or even tanks in a military context. So next slide, please. And if I just take that technology point a little bit further, this is a clever slide I borrowed from the recent Regulatory Horizons Council report on the future regulation of space technologies. You can see that there's a whole range of technologies at the bottom there that are helping drive capabilities in space. And these can be either technologies that thrive in space, such as space-based internet servers. We don't have them yet, but potentially they have a huge role in space because obviously you have a ready source of power, solar energy, but also an incredibly cold environment that can help you radiate away the heat that those servers naturally produce. You can also have bespoke medicines produced in space. Molecular development can be much more efficient and one can generate much purer compounds in the absence of gravity. And then there's technology that can help us operate in space, AI, as I mentioned, but also robotics. And we'll come back to this slide at the end of the presentation. So anyway, getting back to the focus of this talk, there's a short animation, which unfortunately we couldn't make the sound work for, but don't worry. What this slide shows is the vast growth in objects in space over the last 60 years. Thanks very much. As you can see, there are a huge number of objects, satellites, but also inactive satellites and debris now circulating the Earth. And this slide was produced in 2013, as you can see. at a time when people were already very concerned about debris. As you'll see now, the reasons to be concerned about debris are much, much more significant. I'll just illustrate that in a few numbers. Next slide, please. This shows you the number of operating satellites in space, and this is apparent from this graph. Up until about 2012, the population was relatively stable at about 1,000 satellites. Since 2012, there's been a vast increase, and indeed, this slide itself is a little bit out of date, 2022. But between 2020 and 2022, which we'll all recall was the period of COVID, we still had a doubling of the number of satellites in space. And indeed, at the end of 2023, this number now stands closer to 10,000. Projecting forward, it's anybody's guess as to where that number might ultimately get to. If you operate a satellite, you almost certainly need to communicate with it by radio waves. And in order to do that, you need to seek approval from the International Telecommunications Union. By doing so, you essentially file a notification of the intention to use a certain band of the electromagnetic frequency. And there are currently filings with the ITU for 1.7 million satellites to be launched in the next 10 to 15 years. Now, almost certainly that number won't all actually be launched, but a very large proportion of them, I suspect, will be. So next slide, please. What satellites are we talking about? Well, you've probably heard of the Starlink constellation that Elon Musk's company SpaceX have been developing. So this is what we call a constellation, i.e. a group of satellites that are acting in concert. They're relatively close to the Earth at about 500 kilometers above the Earth's surface, so this actually exaggerates their distance from the Earth. Musk has already launched 5,000 of those satellites. He's aiming for over 40,000 in total, and there are more constellations planned. This year, the Chinese will be launching the first satellites in their G60 communication satellite constellation, aiming for a total of about 12,000. And Jeff Bezos is in on the act too. Amazon are launching their Kuiper system, as it's called, aiming for 3,000 satellites in a communications constellation to start launching in 2026. There's also been a big increase in the Earth observation satellites that I mentioned, not perhaps quite to the scale of communication satellites, but there were only 200 Earth observing satellites in orbit in 2014. Today, 10 years later, there are over 1,000, the majority of which are commercially owned by 2 companies. Next slide, please. Another way of looking at this is by size. You can see that, and number, you can see that in the last 4 or 5 years, those communications satellites in the light blue have suddenly burst on the scene. And they're not only a problem in terms of their number, they're also a problem in terms of their size. They're between 100 and 1,000 kilograms, and therefore we've been putting quite a lot of mass into orbit. Before that, people were a little bit more concerned about the CubeSats that I mentioned earlier that were going up, and those are the sort of dark blue colour down below. But A, there are far fewer of them, and B, they're much smaller, less than 10 kilos typically. Next slide, please. And then finally, this is a chart. Again, it's a year or two out of date and would be almost certainly closer to 40,000 now in terms of the total number of objects above 10 centimeters in diameter that are circulating the Earth. These are the objects that can be tracked from the Earth, and believe it or not, the US in the lead are actively tracking all of these objects to see what they're doing. Why? Because they're a huge hazard to active satellites that need to move out of the way of them if they're at risk of collision. Out of this 30,000, approximately 90% is debris, either inactive satellites, rockets. The upper stages of rockets have traditionally just been left to float around in orbit, creating a hazard to other satellites. And then those satellites and rockets have themselves, in many cases, broken up either through explosions internally with fuel that's been left on board, or in some occasions collisions have occurred. There's a couple of sharp increases in the total number of objects around 2010, which are attributable to actual collisions between satellites. So on to what's the problem with debris. Well, as I mentioned, if we can move on to the next slide, Debris is a huge issue for satellites. If it hits you, it's going to cause you major damage. Why is that? Well, because everything in space is moving very fast, and that's what keeps it in orbit. I said there wouldn't be any equation, so I resisted a simple equation here. But in essence, what keeps you in orbit is the fact that you're moving so fast that as you fall towards the Earth, your deviation from a straight line is just enough to keep you in a circle around the Earth. But as you can imagine, if you're dropping straight down to the Earth, you're moving quite fast. So you need to be moving fast horizontally to counteract that. And to stay in orbit just above the Earth's surface at the sort of 500 to 1,000 kilometer level that we were just talking about, the speed required is 7 kilometers a second. That might not mean very much. So to put that into multiples of the speed of sound, it's 25 times the speed of sound, Mach 25, which is absolutely enormous. I mean, bullets travel at less than the speed of sound. So we're talking about something traveling at least 25 times the speed of a bullet. And if a piece of metal, 1 centimeter of diameter, in this case an aluminium ball bearing, goes into a block of metal, you can see what damage it causes. So next slide, please. I said I'd come back to astronauts, which I will in a moment, but here, first of all, is the impact of debris on a satellite. This is one of the European Copernicus Earth observation satellites. It was hit by a very small piece of debris about a year ago, and it's knocked out part of its solar panels. It was almost certainly a tiny piece of debris, otherwise it would have done a lot more damage. Speculation is it could even have been a speck of dry paint which had come off another satellite or a rocket body. So as I said I'd come back to astronauts, and here's a series of photographs showing the damage that's been done to the, if we can have the next slide, to the International Space Station and astronaut spacesuits during spacewalks. In the top right corner in particular, you can see a 2 centimeter cut across an astronaut's glove, which is probably caused by a millimeter sized piece of debris. And when the ISS was being designed, NASA calculated that the risk of a fatal debris strike on an astronaut spacesuit during a spacewalk and concluded that it was about 1 in 10 over the lifetime of the ISS. So they've essentially been playing Russian roulette during all those spacewalks, and thankfully none of them did result in a fatality. So now I'm going to move on to perhaps what we're doing to try and solve this problem, and then talk about the opportunities for the UK and the City of London. If we can have the next slide, please. So what are we doing about this? Well, the first thing to say is that space is very lightly regulated. The 1967 UN Outer Space Act and subsequent UN legislation sets out some basic rules on liability, but these have never been tested and would be very hard to implement. One would need to attribute the cause of a collision. There have been some collisions involving actual satellites, as I mentioned, where you can clearly identify the cause of that collision, but a lot of collisions have or are likely to involve simply pieces of debris. And knowing where that debris came from would be very challenging, although I'll come on to possible solutions to that. One would need proof of negligence. Currently, one is only liable for compensation if one can prove negligence on the part of the operator, and there would be have to be a willingness to navigate a claims process, which is really very challenging and starts with a member state to member state engagement, because only member states are actually formally liable under the United Nations Outer Space Act. So it's a bit like if your car gets hit by a foreign tourist on holiday, you've actually got to go to the government to ask them to make a claim against, for example, the French government. Just imagine, it would be an incredibly difficult process. So really best practice is developed largely according to voluntary guidelines to date. The most important of which, arguably, is the set of UN guidelines, top left-hand corner, which encourage the disposal of satellites after they've completed their operational life. And these formally came into effect in 2019. Excuse me. In particular, they set out an expectation that satellites should be deorbited, which means being sent back into the Earth's atmosphere to burn up within 25 years after completing their operational life. Now, these guidelines, unfortunately, have not always been followed. They are purely voluntary. And in order to achieve that burn-up, one has to use fuel, propellant on the satellite to essentially push it back down into the Earth's atmosphere. Using that fuel shortens the satellite's operational life. So we have situations where commercial operators are looking to maximize their return, or indeed, very significantly, military satellites are considered so important to national security that their lives cannot be shortened. Another problem with these guidelines is they're arguably far too light. They've been negotiated on consensus with unanimity in the UN. And with orbits becoming more and more congested, as we've just seen, the probability of collision is going up, and leaving satellites in orbit for 25 years after their operational life is arguably far too long. So as a result, there have been several initiatives towards more demanding regulation. Top right-hand corner, the US Federal Communications Commission, interestingly, not a body that is primarily responsible for space, but for the management of the electromagnetic spectrum, surprised a lot of people when it unilaterally declared an intention to apply a 5-year deorbiting rule in 2022. And the European Commission has signalled its intention to bring in a new space law which would impose presumably tougher, but as yet unspecified, harmonised requirements across the EU. But clearly any regulation would require effective enforcement. And the FCC, notably, was the first regulator to fine the operator of a satellite recently, fining the operators of an EchoStar satellite, a communication satellite, $150,000 for not deorbiting as it was required to do. Next slide, please. So the second major area which is being considered is to directly remove abandoned satellites from orbit. This is really getting quite James Bond now. And this would require us to remove the most risky pieces of debris mechanically. So there are a number of large satellites and rocket bodies in particularly busy orbits which are presenting a massive risk of breakup and creation of debris at the moment. And several countries and private sector companies are developing technology to capture these orbits and capture these satellites and then push them back into the Earth's atmosphere to burn up. But as you can see with this illustration, which is of the Swiss ClearSpace proposal, it's not easy to do. Essentially, you've got to grapple with the satellite and then somehow push it back down. And then finally, there are a number of initiatives aimed at reducing the probability of collision and in particular, reducing the risk of collision within managed constellations, the sort of which we were talking about earlier, where a satellite becoming defunct and floating around as debris poses a direct risk to the other satellites in that operator's constellation. And this is being described as cooperative deorbiting. It's much easier because essentially you can plan a docking mechanism from the outset. And the one you can see here on the right is being developed by Astroscale, who in fact gave a talk earlier in this series. Some of you might have attended it. And this is their ELSA-M mission, which should hopefully launch soon, and which would demonstrate the deorbiting of a OneWeb satellite. Next slide, please. Within my team, we've also been working on industry-driven initiatives to reduce debris. And indeed, we are working with industry towards what we're calling a zero debris future, and published a jointly developed zero debris charter recently. And the concept here is really to try and strive for much more demanding technical standards in debris management, again on a voluntary basis, but directly with industry, and then to work with industry to develop the technical capabilities to deliver on that. And so this charter that we developed is 10 or perhaps even arguably 100 times more demanding than the UN guidelines that I mentioned earlier. And so far we've had very good sign-up. 12 of the ESA's member states have signed the charter in May, and then 40 industrial players, including some of the biggest in Europe, signed up to it early in June. As I said, the concept is really then to drive technology development, so that might be in areas such as automated collision avoidance, but also in better monitoring debris and avoiding collisions. As I mentioned, We can only at the moment monitor 10 centimetre diameter objects from the Earth. That poses a big problem because objects smaller than 10 centimetres can still cause collisions. So there are companies like Leo Labs that are actually looking to provide a commercial monitoring service at a higher level of confidence and automating that whole process. Next slide, please. So within the UK, there's also a big push towards regulation. I mentioned the Regulatory Horizons Council and its report on the future regulation of space technologies has a big focus on space debris, and the UK government is actively considering what it could do to promote the sector and also effectively regulate it. And the King himself is even getting involved in this. He's promoted something he's called the Astra Charter, which is an initiative to encourage the sustainable use of space, and this was published last year. So my final slide, Jacopo, I hope you'll be pleased to hear this. Really, so what does this mean in terms of opportunities for the UK and the City of London? So if we can have the next clip, please. This was the slide that I showed earlier, taken from that Regulatory Futures report. And what I didn't show you was the top level, really, which is what is being described as the regulation level. But in a sense, I would describe this as the secondary services level. So as any market matures and becomes more complex with greater interactions, there are necessarily a lot of then secondary services that need to be provided. And obviously, within the City of London, there are some direct opportunities to be involved in the development of this very rapidly growing space sector through investment. And we're seeing that already with the first venture capital space company in the world being based in the City of London, Seraphim. But there are associated areas that are more complex and more regulated sector are almost certainly going to open up to a centre of excellence like the City of London. So first, within the financial services sector, there is the insurance market. The UK is already a provider of 25% of the total global space insurance market. And one suggestion is that the UK could be the base for a space-based reinsurance pool to deal with the kind of rare but very expensive risks that can occur in space. The Lord Mayor himself has come forward with a proposal for space bonds, which would guarantee the deorbiting of satellites that were either left by accident or deliberately in orbit. And this is something that he's proposed the City of London could lead on. And supporting this kind of risk-based work would require an underpinning of economic analysis and data modelling, which again is a very big and growing strength of the city. And the second and the last area I just wanted to focus on is dispute resolution. As it becomes possible to track debris more accurately, it may also be possible to attribute with confidence debris that causes further collisions. There are suggestions even of molecular tagging. I don't claim to be an expert in that, but which could enable us to then identify subsequent consequences of perhaps leaving a satellite in orbit, it disintegrating and then causing a chain reaction, which could then lead to claims for damages. But for this to happen, as I mentioned, there's a very challenging legislative environment. That could be overcome potentially through arbitration. And again, the Regulatory Futures Council have proposed a space arbitration faculty, which would be a panel of specialist arbitrators with a dedicated secretariat promoting the English legal system as preferred framework for dispute resolution. So I hope I've given you a sense of how amazingly rapidly the space sector is growing, some of the opportunities and problems, especially around space debris with that, and then some of the opportunities in particular the City of London may be well poised to take advantage of. And with that, I'll hand back to Jacopo. Thank you.
Well, Graham, thank you so much for this fantastic presentation. So we already have some questions coming in, but first I'll have a personal question because we talk a lot about space, but I know you're a physicist, but my question is, would you like in the future to ever go to space and be an astronaut?
Yeah, thanks, Jacopo. So I would, but it is a very risky undertaking. So I mentioned the probability that, 10% probability of fatal impact on an astronaut spacesuit. I certainly wouldn't be volunteering for a spacewalk, but even launch has very sadly proved to be an extremely risky activity for astronauts with around a 1% fatality rate. So first of all, I think I'd like to see that the safety of launch and human launch improve, and secondly, I might save it for a little bit later on in my life, where there's perhaps a little bit less at stake.
Understandable. Yeah. So the first question is how much money are lost, let's say, every time a debris hits a satellite or an international space station? Like, is there what is the loss in terms of money or resources for any space agency?
Yeah, good question. So I'm probably less well placed to answer for the space station. I mean, in some ways, the money is lost by having to build in resilience to deal with small debris strikes. So, the space station or astronaut spacesuits, have to be built to withstand impacts, small impacts, and that will add almost certainly, millions to, if not hundreds of millions. I mean, the International Space Station is the most expensive human-built object. It's not on Earth, but built by humans. It cost over 100 billion to build, and I'm absolutely certain a large part of that cost will have gone into ensuring that it can withstand small meteorite and debris strikes. Then, when it comes to a satellite being destroyed, you're talking about the cost of the satellite, which can be anything from sort of hundreds of thousands, but more usually into the sort of millions, tens of millions. So we're talking about expensive kit here, and then actually a lot of the cost is not so much in the destruction, but in the need to avoid collision. So the normal response to a potential collision is to get out of the way, and that uses up satellite propellant, which is used normally to keep the satellite in its orbit. And then every time you use up propellant to avoid a collision, you're effectively shortening the life of the satellite. And again, that has a cost.
All right. So just a question from Charles. What's the best case scenario for advance warning on early stage Kessler syndrome? And would this give us time to resolve the issue? And also to consider uh, would parties mobilize relatively quickly? Consider all the issues that we're having on Earth, consider like the plastics in the ocean and all the environmental issues that we're facing at the moment.
Yeah, so it's a very good question. So I did mention the Kessler syndrome briefly, but just so that everyone else is clear, so basically a chain reaction where you have, a bit like a chain reaction in a sort of nuclear device where you have one collision that causes debris that then causes multiple other collisions. And under the sort of most extreme version of the Kessler syndrome, the whole of space is wiped out, in a relatively short period of time. I mean, at the moment, there's quite a lot of modelling going on to see, just what might sort of tip us over the balance, because it's quite difficult to model this sort of thing, and it partly depends on how effectively we can avoid collisions through the sort of thing that I've described. So I don't think anyone believes that we're close to a serious Kessler syndrome at the moment, but it's very hard to predict how many satellites there'll be in the future. As I said, it could be over 1 million. So yeah, that's a good question, and it's definitely something that's being looked at with enough urgency. I don't know, but my sense is if the whole world realised that there was a very good probability of losing access to space, I think we would get more action. What gives me hope for that is that radio frequencies are very actively managed on a global basis by the International Telecommunications Union. So, the idea that somehow we just can't solve these things globally, I think, is a bit of a sort of is a bit of a counsel of despair.
All right. Another question from Paul. Considering the large items in orbit, what is the potential impact assessment to issues regarding emergency planning and environmental aspects on the Earth?
Yes, I don't know if that's a question about the environmental impacts of deorbiting, but that is certainly a growing concern now that, well, first of all, launch itself can release pollutants into the atmosphere, and then, it sounds very easy to burn stuff up in the atmosphere, but it's a bit like saying, well, it doesn't matter if we burn all our waste in incinerators, something comes out of that process and again potentially causes pollution. So there's a lot of work is going on again to try and reduce the polluting aspects of launch using propellants that are fundamentally less polluting. You know, if you use hydrogen or oxygen, you've essentially just created water vapor. Now, water vapor itself is not totally benign. It's a greenhouse gas in itself, but perhaps less problematic than CO2. So no, it's an important area of concern, and I would say over the last 2 years has been getting a lot more attention.
All right, I see. So another question from Chris. With large space-based solar power collectors being proposed, has the impact of space debris been considered on their operational requirements?
Yeah, so very, very good question. I mean, those are likely to be out in geostationary orbit, so that they can maintain station over a fixed point on the Earth, and obviously make it a lot easier to then beam the power back down to Earth. There is a lot less debris out in those geostationary orbits. It's a good question. I haven't actually directly asked. I suspect it's a slightly less concern, but I have colleagues here in ESA working on exactly this project, and I will follow up, and if I can get an answer, I'll feed it back through Jacopo. But I would imagine that the network of space-based solar power is being designed so that it is resilient to a small strike on one component.
Great. Oh yes, just a reminder, all the details from the questions will be passed on to Graham, so if there's no chance to answer your question due to time, we will pass on the questions, and hopefully he'll follow up. All right.
Right.
That is
Great. I know what I know what I'm doing for my summer holidays now. Thanks, Jacopo.
okay. Perfect. All right. Just another question, space related, and mainly about solution. So we talked about using like a sort of mechanical solution to remove space debris, but my question is why not pushing debris further in space, like to more remote regions of the space that would
Yeah.
not affect
No,
the
so
orbit
good
of Earth?
question. So I didn't talk about that simply because I didn't want to make the talk too complicated. But indeed, that is the only really practicable solution for satellites that are much further away from Earth. So, you know, TV satellites are generally at what we call the geostationary orbit because it's a special orbit where they maintain an apparently fixed position above the surface of the Earth, and therefore your satellite aerial doesn't have to be constantly moving to pick up the signal. That's at 36,000 kilometers from the center of the Earth, and bringing those back into the Earth's orbit and burning them up, which itself would be difficult because they're very large, typically 1,000 tons, size of a bus, is just not regarded as feasible. So they are generally pushed out into what's called a graveyard orbit, a little bit further on beyond the geostationary orbit. And indeed, the satellite I mentioned that was fined $150,000 was fined because it wasn't moved out into that graveyard orbit. Because again, even moving out into that graveyard orbit costs propellant.
All right, thank you. A question more related to the City of London from Catherine. So, what can we learn from how the City of London uses its influence to promote sustainability on Earth that could also be applied to promote sustainability in space?
Great question. So, I'm really pleased that the City of London is now getting very engaged in space. There's a project that's been initiated, which I was fortunate to be invited along to a few meetings of earlier this year. It's more focused, I would say, at this stage on what are the economic opportunities for London in this very rapidly growing space sector. But I think absolutely, one of the angles that could be followed up would be an ethical one on space sustainability. And as I say, this is something that the King himself has emphasised very strongly. So I think good point, good opportunity there, I think, to link to sustainability credentials.
Thank you. And as I mentioned before, the Lord Mayor is investing in the issue, so the City of London is really contributing. Let's go to a more finance-related question. So, aside from the space bonds that you mentioned before, how would cleanup projects secure funding, given that this does not appear to be revenue-generating ventures?
Yeah, so the only way they're really going to be revenue-generating ventures, well, no, actually, let's backtrack. The active debris removal by constellation operators is almost certainly going to happen because those operators themselves want it to happen. Because as I say, they are suffering the direct consequences of their own debris. It's a bit like, dumping rubbish in your own garden. You're ultimately the one that's going to suffer from it. So you're probably going to do something about it. The debris removal that doesn't have a direct incentive is the removal of dead satellites in congested sort of orbits where multiple operators are active. And there, almost certainly, one would need a regulatory requirement to remove those satellites. It might be that some governments decide that they're just going to band together and remove them and pay for it themselves. But either way, there's going to have to be a decision to do it and then a requirement to pay for it.
Okay, thank you. So just one last question. So is there, let's say, how can public awareness about space debris how can it be improved and why is it important? Like we have a lot of awareness on a lot of topics that environmental related, but can the public awareness affect the issue of space debris and yeah, in a positive way, I would say?
Yeah, well, I mean, it's I think public awareness is always important, especially because ultimately, when public money has to be spent, public support for that spend is important. Or indeed, if regulation needs to be brought in again, public support is important. Also, the public can play a role as consumers of products that are coming from space, and as we've seen in other industries, the consumer can exert backwards pressure down the supply chain for sustainable behaviour. So then the question is, how do we get public awareness? I mean, my view is we try and tap into the public's vast interest in rockets and astronauts. And every time an astronaut appears on TV, then we need to ask them to talk about space sustainability, which I would say they are doing. They are certainly doing more these days, and indeed within ESA, we've just been talking to the person that manages the public relations for our astronauts about how we can engage them in helping us in this topic.
Okay, thank you. Only if we have a minute, only one last question, which I think is quite interesting. Our night sky will change from Chris. So he says our night sky will change forever when Elon's 40,000 satellites are orbiting. Is there any concern that you have about this topic?
Well, yeah, I mean, I think it was a little bit of a sort of unintended consequence. I don't want to make it sound too uh, much as though it isn't a serious problem, but
Yeah.
apparently I'm not a great expert in this. As soon as this problem was identified, Elon simply started painting his satellites black, and I think that has largely sort of addressed this problem of all these very reflective objects appearing in the night sky, messing up serious and amateur astronomy, which is not to say amateur astronomy isn't serious as well. So yeah, it's night sky pollution is an important issue, but I think there are some fairly sort of simple low-tech solutions out there.
Okay, thank you. Well, I'm afraid that we're running out of time, so if we can just go to the next slide to see the upcoming lectures. So yeah, we have lots of interesting lecture upcoming. So we have Autism Approaches, sponsored by the Worshipful Company of Clovers. Then we have another lecture from the Worshipful Company of Water Conservators about sustainability, circular ecology, and circular economy. And then we have Investment Opportunities to Use Science by Professor Jim Lynch. Well, our lecture is concluded. I want to first of all thank you, Graham, for attending here with us today and for delivering this incredible lecture about space debris. And I hope that the awareness has grown after this lecture. We will look at the space more often now and see for any space debris, I guess. Of course, a big thank you to the audience, who is a big part of this series and has been supporting this series in the past months. And I really hope it will support for the next months until our Lord Mayor is in charge. Of course, thank you to Professor Michael Manelli, our Lord Mayor, for sponsoring this series. And well, so I want to just remind you that all the lectures are recorded, and the recording of this lecture will be available in the next couple of days on knowledgemouse.net. Well, thank you, Graham, and let's not forget the mayoral theme of the year, Connect to Prosper. Thank you.